In this lecture, we will discuss the last case of block diagram algebra. That is conversion to unity feedback. We have two systems, G1 and G2. They are connected in feedback arrangement. We know the transfer function for the feedback arrangement is from R to Y. The numerator is the forward path gain. That's G1. The denominator is 1 minus the loop gain. That is minus G1 times G2. So we have 1 plus G1 times G2 as the denominator. So let's change the gain in the feedback loop G2 to 1. Now let me draw the block diagram. And let's see what change we need for the block diagram to make it unity feedback. When you look at this block diagram, then we know the transfer function in this case is y over r. The numerator is still G1. There's a forward path gain. Then the denominator is 1 minus the loop gain. It's 1 plus G1. Clearly, we need to do something to make y and r have the same mathematical relationship. We can think it in this way. We have a summing point here and a block. It's like we use the case of moving the summer and the block in a reverse way. Like in the case of moving the summer. So we have sum first, then multiplication. Now you see here, we have the multiplication first, then take the sum. When we have the multiplication first, then we can change it to the sum first, then the multiplication. Then what we can do, let's write the R here. Let's extend the line. let's say we have G2 1 over G2, then we have the input R. Now you see in this case, we have the multiplication first. Consider here as a new input. We have the multiplication first, then the sum. Now we can move G2 to the other side, which means we have the sum first, then multiplication. Then it will become 1 over G2 R. Then we move G2 here. Then G1. Now let's recalculate the transfer function for the lower block diagram. The forward path gain is 1 over G2 times 1 over G2 times G2 times G1. That is G1. Then the loop gain 1 minus G1 G2. Then the denominator is 1 plus G1 G2. Now you see they have the same transfer function. So that's the block diagram algebra converting to unity feedback. Why do we want to convert to unity feedback? Because later on, we will develop algorithms or formulas for the unity feedback. We will consider the unity feedback as standard of the negative feedback.